What we'd like to introduce to you right now is this idea about a system or systems of linear equations. What a system is where you have more than one linear equation. And that if we were to solve this system, we're looking for the point where the two lines or the two equations intersect each other. So for example, here is a system. You notice that there's two equations and two unknowns. If I were to graph each of those lines, as I did here, you would see that those two lines intersect, and they intersect at one point. And we would call this point, wherever it intersects at, we would call it the solution to this system. Now, some systems have one solution. Some have no solutions, and some have an infinitely many solutions, of which we'll talk about as we proceed through this series here. So, just to recap, we're looking at how to solve a system or systems of linear equations where there's two variables. It is written in a form where I have two equations on top of each other. That's a traditional format. And when I see that, I would see that that's a system. And the solution of that is, what are the values of x and y that make both of those equations true? One way to solve it is by graphing it and trying to get an idea what that point is at. However, graphing sometimes is limited because we can't precisely figure out what that point is. So let's just back up a little bit and get an idea of, well, what does this mean if we're looking for a solution to this system here? So imagine that I'm curious about the point 4 and 1. That's a coordinate point, meaning it's a location on my graph. Is this a solution to both of these equations? Well, what we would look at doing then is let's look at that first equation up there and let's put in 4 and 1 and see if that makes it true. Solving that out, 4 plus, oh, that's a negative 1. Whoops, sorry folks. Four plus a negative 2 equal 2. Does 2 equal 2? That is true. Let's find out if that solution works in this second set as well. So we would have our x and you would see that I would get a true statement. So what that tells me, like we discovered before, that if we find an ordered pair, put it into the equation, and the equation makes it true, then it's a good ordered pair. It's on that line. This one's a little different though, as we're looking for to find out if this point's on both lines. And we saw that that one is indeed the case. Now to contrast that, let's look at another point. Let's look at maybe the point 4 and negative 3. What would that look like? Same process. Work that out. Putting that point into that first equation, I see that I get a value that makes it not true. Negative 2 equals 2, that's not a true statement. So therefore, I know that this ordered pair is not a solution to this first equation right there. If it's not a solution to the first equation, then we know it's not a solution to the entire system. So one way we can check to see if we have a solution is by plugging it into both equations within the system, and then from there. And like we mentioned earlier, we also have the ability to graph these lines as well and kind of get a sense of where is the solution at.